Assalamualaikum warahmatullahi wabarakatuh. Very good evening to everyone. So thank you guys for joining me on tonight's media session. I would like to know whether we are still waiting for other students, or I think we can start right away because I think they can just join whenever they want. Okay. All right. So just to double check, make sure I record everything. Okay. Okay. I think we can start now. All right. So for today, what we're going to do is first we are going to look at the amendment of the FYP calendar due to COVID-19, which I already shared in our Facebook group. Then a bit of recap on the last workshop, and we are going to continue with chapter 4 and 5 today, hopefully. Okay. So if you got any question, you can either speak up or you can use the chat function over here. All right. So first of all, regarding the amendment of the academic calendar, just a reminder: this is applicable for our school only. I'm not sure about the other schools. Okay. So basically, the highlighted points over here is point number 2, for example. Okay. So for all FYP1 students, your assessment will be completed during this semester. So meaning that for FYP1, we have proposal defense, which is due or which will be conducted in 2 weeks' time. And we also have the submission of your progress report. Submission of progress report. I think this is in week 12. Okay, week 12 or 13. Okay. So for FYP1, all assessment, proposal defense, and submission of your report will be conducted or will be done during this semester. Okay, so proposal defense will be done online, the assessment. Submission of progress report, of course, it can be done online as well. Okay, next, for point number 3, okay, so upon discussion with the TDA, Dr. Khairul, so for FYP2, this course will be extended to short semester. Okay, now, regardless of whether you are doing experimental work or simulation work, whether you can finish your work this semester or not, all assessment will be conducted during the short semester. Okay, so evaluation of oral presentation, submission of final project report, and logbook will be done during the during the short semester. Okay.
Excuse me.
Yes. Yes, please. Go ahead.
Doctor,
Yeah.
there is a pop out in your screen.
Come again?
There is a pop out in your screen. A lonely screen AirPlay receiver.
I see nothing on my screen. What does it say basically? Oh, okay. All right. Thank you. Okay. How about now?
Yes, it's gone.
It's gone. All right. Thank you. Thank you, Surya, for the note. Okay. Okay. So let's continue. Okay. So for just 1 second. Okay. So for FYP2, basically, just look at it as having an extension or extra 7 weeks of the normal semester. Yes, I see some students, or better, okay, you were referring to the pop-ups. Okay. So basically you have an roughly extra 7 weeks to complete your project. Okay. Of course, for those doing the experimental work, there's nothing that you can do. Basically, you have to wait until the short semester to finish your work. But you can spend the 7 weeks, the extra 7 weeks, to basically to touch up or to improve your report. Okay, basically just conduct the experiment during the short sem and finish it, the conclusion. Okay. Don't worry, I'll share the attendance link later on. Don't worry. Okay. Next, okay, about point number 4. Okay, it has not been decided yet on the school or at the university level. So what I gather from discussion with our TDA, Dr. Khairul, what he said is most probably all students FYP2 will obtain TL. Okay, TL means tidak lengkap, not completed. Uh, I'll go back to the attendance later. Okay, let me finish this one first. Okay, so you will get TL or most probably yes, TL, I'm sorry. So most probably you'll get TL on your transcript. Okay, so the good thing about TL is when you register again for the short semester for FYP2, so your grades in the short semester will replace the TL during this semester. So basically you will not getting any TL lah on your transcript, on your final transcript. Okay, so that's the case for FYP2. Hopefully I make myself clear. Regardless of experimental work or simulation work, all assessment will be done during the short semester. Okay. However, point number 6, the school, the committee, we encourage all students to complete your project if possible during this semester. So I know it's quite impossible for those who requires a lab, okay, but as I said, make use of this extra 7 weeks. Okay, either you, as I said previously, if possible, if you can convert your experimental work into simulation work, please do so. But you have to discuss with your supervisor. Okay, you can't decide on your own to just convert the project from experimental work to simulation. Okay, everything must be discussed with your supervisor. Okay, so if we look at the tentative, the amendment of the calendar, okay, the shaded area is basically what we finish lah, what we accomplish before the PKP or MCO. Okay, so roughly the same things as the normal semester, but you remember basically when we started on the 6th of April, that is the new 7th week of your academic calendar. Okay, so basically what we have is 7 week, this is week 7, 6 April. So other than that, everything else is the same. I think all FYP1 students already submitted the proposal submission to their supervisor. And then we are having tonight report writing part 2. And then we have another workshop scheduled, I think next week or the week after, for latex template, FYP latex template by Mr. Hasrizal. Okay, and then we have a workshop by Prof. Hamid, and then another workshop on presentation preparation. And then for FYP1, stated over here, you have the logbook and progress report submission scheduled on week 13. But as I said, if it is due on week 13, you have to give, or you need to finish the work by week 11 so that your supervisor can spend at least a couple of days to check your work by week 12. Okay. Then for FYP1, you have to submit your FYP1 week 13 submission. I think that's it. Other than that, FYP2, there's nothing concerns you for the calendar. What are the third and fourth column? Activities and comment. Basically, this is the activity, which is what we plan for you, what you have to submit and everything. On the fourth column is basically who or what do you need to submit, when, the details lah basically. Okay. Alright, so any questions regarding the amendment of the academic calendar? I think it relates more to FYP1 than FYP2, because as I said, FYP2 you have to do short semester, but anyway. Yes, I think I told you guys the maximum capacity for today's session is 75 students. Okay, I think I told you. So that's why I only open this session for mechanical students. Okay. All right. So any questions regarding the calendar? Uh, well, short SEM, additional SEM. I think the right term is the short SEM basically. So you have to complete everything in the short SEM. Yes. Well, that's why I said technically it's not quite accurate because you already did some work for the past 7 weeks and then you add another 7 weeks to finish your work. But yeah, they call it short SEM. So it doesn't matter short SEM or additional SEM. Okay, as long as you can finish your FYP. Okay, any other questions before we proceed to the thesis discussion? Okay, so we discussed about the amendment. So a bit of recap. Okay, so since I assume majority of the students in these sessions are from mechanical background, so I already highlighted the following points, the important points from the last workshop, which you can look back in the posting in our FYP page. Okay, so I'm not going to go through in details, point by points, just so that you know, I already posted this couple of weeks now. Okay, all right. So I hope you spend a bit of time to read and understand each of the points. Okay, so we got chapter 1, chapter 2, and also chapter 3 previously that we covered in the last workshop. Doctor, I already shared these important points, highlights from the workshop, the first part, on the do's and don'ts of each chapters. We got chapter 1 over here, introduction, and then we got chapter 2 and chapter 3 over here, literature review and methodology. I hope you pay attention or you have a look at these points before you start writing your final thesis. Okay, all right. So I think generally what I want to highlight is this here. I think all students should follow these basically guidelines in writing your report or your thesis. Okay, so basically, abstract is the part that you write last, the final part. Okay, after you finish a conclusion, then you write the abstract, because abstract comprises the information from introduction, literature up until the conclusion, the result. Okay, this should be the last thing that you write on your thesis. So I think we covered introduction. Okay, see the shape, generally the hourglass shape. You started with something general and then you go into specific. And then we covered literature review. Similarly, see the shapes. You started with something general and then it goes more into details. Okay, methodology. This is, I think, one of the most critical part. If you want people to basically be able to replicate your project, your methodology must be very, very clear and very, very detailed. Okay, you need to explain in great detail. For example, if you are doing if you are doing simulation work, what is the boundary condition? What is the meshing size? What is the difference between refined meshing sizes and the coarse meshing sizes? What is the impact on the simulation? You have to discuss that in methodology. Okay, and then this is what we are going to discuss today, which is chapter 4 and then chapter 5 discussion. Okay, any questions so far about the guideline that we have over here? No. Okay, all right. And I think last time I also shared a few examples of what I think is a good flow chart. Okay, I think this is the weakness of our students. I spend a lot of time examining students' thesis, FYP thesis, I noticed most of the flowchart is rather simple. Okay, so most of the students will have start over here, and then you go down, student will write down literature review, and then you write down methodology, okay, and then suddenly you have a decision, and then conclusion or discussion, end. Okay, so this is not what we expect from FYP students. So if you want to be clear, or if you want panels to be impressed to understand your work, at least, okay, even this is not the best, but at least it shows an example of what is expected from the students. Okay, it has to be very detailed. Each of the shapes in the flowchart has a meaning. Okay, if you choose a shape like this, what does it mean? Okay, it has a certain meaning. So make sure you understand what is the meaning of each shape. Okay, for me, I'm more concerned about this shape, the diamond shape. Okay, this is a criteria. Okay, meaning that you have to put a criteria. What makes you decide whether it goes no or proceed with yes? Okay, so you have to be clear in deciding the criteria in the diamond. Okay, all right. So I think let's go back, or let's continue with the thesis that we looked before. Okay. I think most of you guys should notice already the thesis that I shared during the first workshop and the one that we are looking at right now. This is an example of what not to do for your FYP report. I hope you understand that. Okay. Um, so I'm showing students the weakness or things that where students basically needs to improve. Okay. So again, I repeat, this is an example of the thesis or a report that students should not try to follow. Okay, so I think it's quite useful because we can point out the weakness or the problems. Okay, so in results and discussion, okay, before I go into details, what I notice, basically what we notice as the panels, students basically tends to look at the plots or analyze the plot on the face value. Okay, meaning that, for example, okay, if you have a simple graph like this, just a simple plot, okay, which shows a linear plot going basically on a uptrend. Okay, so students basically just says or just look at the plots and say, oh, the plot shows the y and x value of a certain characteristic on an upwards trend. Okay, and then that's it. Okay, so in result and discussion, what you should be doing is first, okay, you put the plot, then you analyze the plot, then you discuss and elaborate. Okay, so what's the difference between point 2 and point 3 over here? Plot is just basically you have a data, you plot a diagram or anything, something that can help you convey your results. Okay, okay. Um, Analyze, as I said, basically you can just analyze, okay, the slope of the graph is blah blah blah. Okay, it shows a trend that is going upwards. Okay, that's analyze. Okay, but discussion and elaboration, why does the slope is a certain value? Why does the plot shows a sine wave, for example? That is elaboration. In this part, what we want you to do is basically relate with uh, things that you have learned before. Okay, for example, maybe you can relate. Okay, the plot shows um, a certain characteristic because of the Bernoulli principle. Okay, Bernoulli principle stated that blah blah blah. So this graph matches the characteristic as explained by the principle. Okay, that's what we look for in chapter 4 from students. Okay, Is everyone okay there? I got some comments saying that you can't hear my voice. Is everyone okay? Okay, good. Okay, all right. So let's see what these students, your senior, did. Okay, so it has an introduction, okay, which is fine. Just a personal note about introduction. Some students basically put introduction or start with introduction on each chapter, which is not necessary. If you got something to say, something important, something relevant, yes, you put introduction. But if you don't have anything important to say, you don't need to say, in this chapter, we will cover all the results obtained, blah, blah, blah. You don't have to do that. Yes, I'm showing something on the screen. Can't you guys see it? Okay, so again, this is just a personal note. It depends on you and also your supervisor. I think that's the most important. If your supervisor is okay, I think you just proceed. But my note, my personal note, um, not necessary. Okay, unless you have something important to say, then just ignore the introduction. Okay, because I think, for example, these students keep on repeating about UTM machines and also the materials that he used before. Okay, I think that is not necessary. Okay, then, for example, okay, this student, okay, they start with 4.2 tensile test analysis. Okay, okay, some specimen. Okay, what happened to the specimen after the tensile test. Okay, then obtain from the data a certain calculation, a certain value. Okay, now look. If you look over here in the apa nama ni? Over here in the data, obtain from the data. A, for example, this is not the proper way to do the equations. Abang, minta switch off the video. Okay. So if you want to do an equation, you have to do it properly. So let's say A, this is 4.1. Okay. This is 4.2 unless this has been declared before. Okay. Now, even if this has been declared before, every time that you introduce an equation or a new symbols, you have to declare A is the area or the cross-sectional area of blah blah blah. D is the diameter of the specimen. So it has to be in detail. Okay, so what you need to do or what students need to do is first, after you put down the equation 4.1, you have to list down what is A, what is D, what is all the F, everything there. Okay. Next, all these symbols that has been declared or has been mentioned in the report must be attached or must be included in the list of symbols in the TOC, okay, table of content.
Recording is on.
Okay, all right. So if you look at over here, these students did not declare any. So, for example, I think we can pretty much understand what is Fmax. But what happens if you are introducing a new symbol or a new what do you call this? A new, what do you call this? It's not symbol. What do you call this? Let's say like PA, whatever the Astaghfirullahaladzim. What do you call this? Is it symbol? Okay, let's say we call this symbol, but only you know the meaning of the symbol. So unit, it's not unit equation. The acronym is like ANG. No, abbreviation. Yes, that's like an acronym. Okay, but let's say you introduce a new variables. Okay, let's call it variables. Okay, so P F and A, I think that's quite common. Yes, we know the meaning of it. Okay, what happens if you introduce something that only you understand from your research? Okay, so it gives uh, some problems for the reader, especially the panels, to understand or to follow the reports if they have some missing information. Okay, so that's why you have to put down why is F max A P, so that the panels, the reader can understand. Okay, okay, and then the student put table 4.1. Okay, now if you look over here, okay, I make it a bit smaller, the text. Okay, now from 4.2, okay, a very short description, and then a few pictures, and then very short calculation, and then tables. Uh, there is no detailing of what the result is all about. Okay, what is the purpose of showing the plot? What is the purpose of showing the figure? What is the purpose of showing the table? It has to be described in detail in the body. Okay, all right. So, for example, suddenly we are discussing about figure 4.3. Okay, how about table 4.1 over here? How about equation 4.1, equation 4.2 over here? How about figure 4.1 and figure 4.2? You have to explain in detail all plots, all tables, all diagrams that you include in your report. There must be a reason why you put it there. Okay, you just can't simply, okay, I have a lot of data, I just want to share in my report, that's it. No. Okay, so whatever you put, figure X, Y, Z, table X, Y, Z, you have to explain this in the body of the paragraph. Okay, meaning that you have to explain in a paragraph this. Okay, so if you just have one paragraph like this, you have 3, 6, roughly about 8 or 9 lines, which covers one, two figures, two equations, and one table, then something is wrong. Okay, so when you have a lot of information, tables, figures, equations, you need at least 2 or 3 short paragraphs to explain what the figures, what the values are about. Okay, just remember, this project, okay, this is your project. Okay, meaning that even though panels who check your thesis has a PhD, it doesn't mean they understand in details what the project is about. Okay, I'll give you a simple example. If I read Dr. Shukri Majid's student's thesis, I might have a problem to understand in details the terminology as well as the methodology that the students use, because his research is about applied mechanics, okay, a very specific area of mechanical engineering. Okay, similarly, if Dr. Shukri Majid check my student's thesis, he might have a difficulty to understand in great details what the project was about. Okay, since my area is fluid dynamics, which is different from uh, his expertise. Okay, so make sure panel and reader understand your project. Okay, so next, if you look at this graph, okay, so this is a stress strain graph. I think we are quite familiar with. Okay, I put some notes over here. How to produce an A plot. Okay, my advice is use MATLAB or R. Okay, I'll show you later an example of plots produced by FYP students, my FYP students, using a MATLAB. The difference between MATLAB plot and the Excel plot. Okay, so if you look at this figure 4.3, okay, so if you look at the description, I give you a couple of seconds. Just read the description by the students. here. Okay, just read this paragraph. Okay, so if you read the paragraph, okay, it is very, very straightforward. Is there anything wrong with it? Maybe not. But remember, if you have plot, you analyze it. Where is the elaboration and discussion? The third part is where the student usually have a problem with. Okay, so this is not what we look for in FYP students, because for FYP project, the FYP level, we expect students to have some critical thinking, meaning that yes, you can plot, yes, you can analyze the plot, but how do you relate the behavior of the plot with what you have learned in the 4 years as a degree, as an engineer over here, mechanical engineer over here. Okay, so the third part is what you need to focus on. Okay, so the same behavior is being repeated in all subsection. Different tests, but different characteristics. So if you look here, okay, it shows here, based on figure 4.4, as you can see over here, this is the characteristic of the materials after a certain load. Okay, and then another figure 4.5. See, this student just use 3 lines in the paragraph to explain about one figure. Okay, and this is not even an explanation, it's just a direct examination. Okay, it's like looking at the paragraph, looking at the figure 4.4, and pointing out, oh, there's a hole in the specimen. Okay, that's not what we look for. Direct examination. You have to offer more than that. Okay, so all this is being repeated. See, try to avoid writing a short paragraph like this. Okay, I think in your thesis, if you have a short paragraph like this, you can combine several of the paragraph into one longer paragraph. Okay, I think I mentioned in the first workshop, if possible, you don't have to write something long in the paragraph. It has to be short, but this is way too short. Okay, it's not even proper. Okay, okay, so the same thing is being repeated. Now, so I think this is again a simple mistake. Figure 4 something. Now, to avoid this mistake, what you can do, you can use cross-referencing function in the words. Okay, you can use both for figure, tables, and others that requires numbering. Okay, I always encourage students to use this one, because more often than not, when you submit your work to your supervisor and panels, you will get a feedback. Okay, for example, I might say to my students, okay, apa nama, Asari, okay, cross figure this, change this figure into chapter 5, for example, or maybe chapter 6. Okay, if you use cross-referencing, if you just copy and paste this figure to another section, it will be updated automatically. So you don't have to change manually. Okay, so it helps you a lot. So use cross-referencing whenever possible. Okay, similarly, it has some plot, figure 4.8, SN curve. Okay, this is what we don't want to see in your plot. Okay, the plot itself is very simple. Okay, what does the plot compare with? Okay, what does this mean? Where is the legend? That's one thing. And then the caption, it has to be detailed. This is an SN curve for material blah 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 conducted for the load of from 0 to something. It has to be detailed. Okay, when I say detail, it doesn't mean long. Okay, but at least when the panels read, it understand, okay, this relate to the experiment that the students conducted, blah blah blah. Okay, so similarly, if you look at the explanation of um, the plots and the paragraph, is very straightforward. Okay, there is no critical thinking or elaboration analysis in the paragraph. Okay, okay. And if you look my comments over here, lacking details, need more analysis and elaboration. Okay, and more importantly, how do you relate the results to the stated objective? So chapter 4, okay, you set chapter 1, you set objective. You have 1, 2, and 3. Chapter 4 is where you prove, okay, I obtained objective 1, 2, and 3 by using a certain method. You have to prove, okay, where does objective 1 achievement, okay, how do you achieve it? Plot A, B, C. So over here, there is no correlation at all. Okay, plus, if you look here, page 38, and chapter 4 is from page 30. Only 8 pages long for results and analysis. So which is not enough. Okay. So this is again, as I said, an example report that you should not follow. Okay. So I'm going to stop for a couple of minutes. Any questions from students? Anyone, please. You can use the chat function or you can ask directly. All right. So chapter 4 should be very, very detailed. Okay, now, before I go to chapter 5, I'm just going to add one page over here to make some notes. Okay, I think most of the students are quite familiar with the formatting of, let's say we have chapter 1, intro, chapter 2, literature review, chapter 3 is methodology, chapter 4, result and discussion, okay, and chapter 5 is the conclusion. Okay, this is the standard. It's not the standard, but the format that usually students usually follow. Okay, how to make correct refer? Okay, is it possible we compare our result with previous result conduct? Okay, what do you mean by that, Hafizul Hadi? Okay, to answer Lee Wei Bin. Okay, okay, so if you have table, it has to be on the top. Caption. Figure, it has to be on the bottom. Let's say you have a figure. Okay, the figure XYZ caption. Okay. Validation, Hafizul Hadi. Yes. You actually, that is the best way. You need to compare your result with previous study. Otherwise, how are you supposed to know your result is right or wrong? Is it possible? Yes. Okay. I will show you after this thesis. I will show you a couple of good theses that you can basically learn something from it. Okay, I'll show you. Lonely screen. Okay, 1 second. Okay, or maybe I can show you right now. Just quickly. Okay. So before I go into details about the validation, let's go back to this standard chapters that students usually follow. Okay, now this is the standard, but it's not written on the stone, meaning that it is up to you to follow or not. Okay, if you have something very, very detailed or very long to discuss or to show in the results chapter 4, what you can do is, okay, you can write chapter 5 discussion. Okay, if you want to focus chapter 4 only on results. Let me continue with chapter 4. You can have result in just in one chapter if you have a specific result that you want to discuss that is quite a lot. Then you can have chapter 5 for discussion of the result and chapter 6 for conclusion. This is usually the typical PhD or master's template. Okay? Because usually in grad they have a lot of results they have to put in. So they have specific dedicated chapter 4 for results and then discussion in another chapter. So it's up to you. Okay, if you think it's better for you to separate result and discussion, please, it's up to you. You can discuss with your supervisor, okay, and you can choose to do that. Okay. So to answer Hafizul Hadi just now, okay. So if I can share one of my students' one of my students' thesis last year. Okay. So this is the plot that he created in MATLAB, by the way, and if you look over here on the legend, the plus sign, that is the experimental result, meaning that he extracted this data from papers, from the journals. Okay, he plotted on the data on his plot, then he used MATLAB to include his data from his simulation and compare to validate the result with the experimental data. Okay, so actually this is the best way. Actually, this is what we expect from the students. If you just did what the previous students do just now, okay, just 1 second. Data, be it simulation or experimental, how are you supposed to know whether what you are doing or what you were doing is correct? Okay, so you need something to validate your data. So actually, for me, you have to compare your data with something. Okay, this is just one example. So for example, okay, so my students did a simulation. So this was his result. Okay, I'm just going to show you some more plots here. This again obtained from the experimental. These are data from the experiment, and the lines were his result. Okay, Hafizul Hadi, hopefully that answers your question. Okay, so if we can continue, okay, with chapter 5. So chapter 5 conclusion. Okay, conclusion. I think most students take things for granted, this chapter especially, because it is the last chapter. It's quite simple, yes, but how do you write a good conclusion? Okay, so now, please don't repeat yourself. So for example, these students, he kept on repeating the same thing from chapter 1, so you don't need that. Okay, so conclusion just highlights what was the key data or the key conclusion or the key output from your result, from your project. Okay, and you write down the key aspect of it. Okay, so it has to be, well, something, it's not novel, but something that hasn't been written in chapter 4 or chapter 3 before. Okay, you have to write in a way that when a good panels, when, okay, for example, in my case, when I receive a thesis, FYP, master or PhD, what I did usually is first look at the abstract, then I will look at the conclusion. If I can understand the abstract and I can understand the conclusion, then I definitely will understand the content of chapter 1 until the chapter before the conclusion. Okay, so it means the conclusion is important as it summarizes all the key information of the project that you did for the past 1 year. Okay, so then after you conclude, then there's another part in the rubric. They ask for recommendation of future project. Okay, for recommendation, what you need to do or what you need to write is something that can be improved. Okay, you conduct this experiment using material A. Okay, but you found out there were many limitations. Okay, now you want to advise, or if possible, if given a chance, what can you improve? Okay, maybe you want to use material B, C, D, and E. Maybe you can use methodology C, D, E, F, G instead of methodology A. So that is something that you want to put in recommendation. It's not putting down School of Mechatronic should consider having a team major in topic fatty crack. Please do not write something like that. Okay, it is something that can improve your project, your current or existing project. Okay ke? Okay, so I've made some notes over here. Abstract should be written at the end. Okay, abstract is the last thing that you write. So that's why I said after you write the conclusion, then you write your abstract because you already have the flow from chapter 1 until chapter 5. So the abstract, it covers everything. Okay, now that's why when the panel, he or she, when they get the thesis, when they read the abstract and they read the conclusion, if they can understand both, that means the students are safe. Okay, that means the content should be okay in between. Okay, I think I haven't really touched about abstract, so I'm just going to go quickly on the abstract a bit later. Okay, but before we end, for references, uh, this is, by the way, the final thesis submitted to the panel for this student. So just look at the references. This is the references that I give as an example in your template. So it just shows you the level of the students lah. Okay, basically he doesn't even have the, I don't know, I'm not sure about the words, but he doesn't even change the template given. Okay, so please don't be like him. So make sure your references, you have it aligned. Okay, and make sure you follow the IEEE format. 1, 2, 3. See the spacing over here. So make sure you follow all this. Okay. Okay. And then when you submitted your FYP2 draft, make sure you include together technical reports and also your turning in receipt as the appendix. Okay. Please do that. Okay. So I'm not going to go through appendix. Appendix, if you have a lot of data that you want to share, please put it in appendix. But I advise you have to mention this in the body. So meaning that you have to mention somewhere. Okay, for more details of the data obtained using method A, please refer to appendix A, B, C, or D. You have to mention this in the body. Okay. So just quickly, if I go to the abstract. Okay. Okay. So the abstract should contain intro, problem statement, your methodology, findings, and conclusion. Okay. So a good abstract usually for FYP level, again, as I said, this is not like a rule, but usually it should be roughly about half page long. Okay. Okay. So it should contain all this intro, problem statement, methodology, findings, and conclusion. So that's why I said abstract should be written at the last phase of your writing. Okay. And my last advice, don't use Google Translate, especially for BM, for bahasa. Okay. Okay. Okay, now I open questions from students. Okay, when to put data in chapter 4 in appendix? Okay, if you have too many data, okay, for example, if you are doing a simulation, okay, let's say you are looking at the optimal size of the meshing. Okay, so meshing is a critical aspect of a simulation, yes, but let's say you tested 10 mesh size. Okay, maybe it's too much to put everything, the 10 results or maybe more in chapter 4 alone. Okay, so what you can do is maybe you can choose, okay, this is an example of 4 meshes, for example, refine, medium, and also coarse, okay, for this project. Okay, more data regarding the mesh size can be referred to in appendix, for example. Okay, so usually you will know, or your supervisor will know, if your data is too much because you keep on repeating the same thing. Okay, let's say you conduct an experiment, the difference between the length that you choose was, let's say, just 0.1 meter. Maybe it's not that important. Okay, so if you did 10 similar measurement, why not put, let's say you want to take the average, so you can just put the average value in chapter 4. The details can be put in the appendix. Do we need to write chapter summary? I personally do not agree or do not like that uh, that that method, Tan. Okay, I personally think chapter summary is not suitable to be written on each chapter. How do you write chapter summary for chapter 1, introduction? You just started to write the thesis, however, suddenly there is a summary for chapter 1. I think, but that's just my opinion. Okay. If analytical FYP, what do you expect in the result? Again, what I expect in the result is a comparison, a validation. Okay, if you're doing something analytical, okay, you came out with a derivation or integration. Okay, so you have to compare what is the base. There must always be a base or a benchmark. Okay, otherwise, why are we doing things? The purpose of FYP, first, you have to understand, is for you to apply the knowledge that you have learned for the past 4 years. But secondly, is for you to basically, to aside from applying the knowledge, you want to further the knowledge, meaning that someone else has done the project already most of the time for FYP, because that's FYP level. Okay, since the project has been done before, how does your result or how does your project improve or differ from the original project? That's what we want to look, Kevin. Okay, so you must always compare your result with something, regardless simulation, experimental, or analytical. Okay, hopefully that answers, Kevin. Tan, what do you mean by other chapters? Tan, for the chapter summary. Okay, again, this is my personal preferences. For my students, at least for my students, I do not ask them to put chapter summary for all the chapters. Okay, if you want to put, if your supervisor asks you to put the chapter summary, I think that depends on you and your supervisor. Okay? But I personally do not like it. Okay, any other questions? You guys can use the microphone, huh? Anyone else? Okay. If you got no question, I would like to share some of the good FYP examples last semester, which is FYP1. And then I'm going to show you a full FYP thesis last semester as well. Okay. This is a thesis of a biomedical engineering student. Okay, Lai Chi Ning. I'm not sure whether you can see or not. This is FYP1 report, progress report. FYP1, but the number of pages is already 78 pages. Okay, I emphasized before in workshop, the first workshop, number of pages does not indicate the quality of the thesis, but at least it shows the effort of the students to do literature review as well as to analyze the data. Okay, so I'm not to go into details. I'm going to make the screen a bit small. Okay, now, so I'm just going to go quickly to highlight the strength of her thesis, FYP1. It's not thesis, a progress report, by the way. Okay, this is not important. FYP1 doesn't have declaration of report. I just made some notes over here. Okay, always use letters format. Okay, acknowledgement, usually panels don't comment much because I think that's your prerogative. You can write whatever you want in this section. Okay, for FYP1, you don't have declaration of report or acknowledgement. I think that's okay, right? Okay. So list of tables. Okay, list of figures. Okay, if you look at over here, if I can highlight over here, see how she arranged the list. Okay, they are perfectly aligned. Just nice. Okay. Okay. List of abbreviation. Remember, you have to arrange alphabetically. A, B, C, D. Okay. So look at the abbreviation that she used. It's very, very detailed and everything is basically compiled in this TOC. Okay. Okay. Look at her introduction. Can you guys still see the text? Or is it too small now? Okay, yeah? Okay. So look at the introduction, just the introduction. We start with project background. Okay, remember, you start with something very general. You don't want to jump straight into the topic. Remember, when you first start your car in the morning, you give a couple of seconds before you start driving your car. Okay, so similar with chapter 1. You give the reader a feel of the topic. So give a general information about breast cancer. Okay, so they give a statistic. Okay, how much breast cancer detected in the world, blah blah blah. All those information, percentage. Okay, remember this is just general information. Then she goes into a bit of detail. It is caused by the cells. Okay, now next, a bit of information about the cells. Okay, so figure for whenever you have a figure, you have to mention in the body. So figure 1.1 is mentioned here. Okay, wow. So after figure 1.1, always have references. Okay, Then she goes about the detection method, okay, because it's getting detail and more detail about the topic. Okay, so she gave one examples of the method, which is by using the screening. Okay, see, she's writing several short paragraph. This is what we want in students. Do not write down one long paragraph because it's very difficult for the panels to read long paragraph. Thank you for the information. Okay. Okay. So after the methods, the screening method, okay, they give the problem about the screen method. Screen method cause or admit radiation which cause genetic mutation. Okay, so it gives the background of the current situation in the world. Okay, now it's getting deeper and deeper into the topic. Okay, so she offers the alternative, okay, by using breast biopsy procedure. Okay, so again, a lot of figures, a lot of discussion. Okay, and of course, you need to put your citation. It's not citation, sorry, references. Okay, okay. So again, so they continue. Okay, with from the figure. What does the figure means? What does the figure mention? Okay, so still going on. Okay, still going on. Okay, so after she introduced all those information, the background study, so something starting from very general and then smaller, getting smaller and smaller and smaller. Now, she wants to highlight what is the problem with the current trend. Okay, so this study will focus on blah blah blah. Okay, the mitotic cell detection. Okay, even I have no idea what this means because this is from biomedical engineering, but it shows the planning. So when you want to write, you have to plan. How do you want to tell the story to your reader? Okay, so if you look at here, she wrote her introduction roughly about 4.5, roughly about 5 pages long. What is the average introduction written by students commonly? Half page or 1 page, not even 1 page. So she wrote 4 pages long, which when I read, at least it gave me some understanding of what the student is trying to do. So instead of just say, oh, I want to study about method B, about method B. We have no idea what is method B, what is method A. So you have to introduce, tell the story. Okay, before you go into method B, tell about method A. And before method A, what is the current trend? What other methods are available there? Okay. Then, after you read 4 pages long of introduction, when you read the problem statement, most of the time, you can understand it because you already have the background from the introduction. Okay. So the problem statement is very, very detailed as well. It's not just one short paragraph. Okay. See, she highlighted the issues. Okay, the current issues. So this is what we want from the students. Tell a story. Okay. Then the objective. Okay, blah blah blah. I think that's okay. And then the scope. Scope is your limitation. Okay. What I want to highlight over scopes is here. Now, if possible, do not write down the software that you use or the software version. Okay. Well, not write down, but be careful of the software version or the software that you use in your study. Only mention the software if it is available in the school, meaning that we have license, we have access to license. Okay, be careful. Okay, so the school will not tolerate basically pirated software. Okay, hopefully that is clear. Okay, Any questions about chapter 1 from the students? Okay, anyone? Open source, very much so. That's why it is called open source. Okay, you can use open source, definitely. It is encouraged. Okay, any other questions? Thank you, Bani. Okay, so for chapter 2, literature, I'm not going to go through because it is biomedical engineering, but just to show you the details of her literature, this is page number 9. Okay, I'm just going to scroll slowly so that you can have a look at her literature. She tells the story, pre-processing, segmentation. What is segmentation? Okay, and all this comes with a proper citation. Okay, always provide citation when you take the information somewhere else. Okay, okay. So I'm going to go quickly over here. Okay, very detailed about the literature. Okay, now I made some notes over here. Use landscape format to highlight important data, plots, or diagram. Sometimes students are afraid to arrange their plots or table using landscape format. Okay, please don't be afraid of using landscape format. It is more than encouraged. I personally like students to show comparison using table because they are much more easier to analyze, to understand. Okay, so for me, use table whenever possible. Okay, so as you can see over here, a lot of references. Okay, and then in great detail, how does the features work? Okay, let's not go through in detail. I just want to highlight again. So everything is done nicely according to the format, arranged carefully, so that it tells the story of what the students were trying to achieve. Okay, so we are still going. See, a lot of tables, if you can see from this literature. Okay, okay. So use table of comparison, and of course Mendeley for citation, because it makes your life easier to use Mendeley. Okay, now if you look at over here, page 30, she started her literature roughly at page 9. So that's what I call a good literature. Okay, so I think in her references, the total number of references were about 46 or roughly about 50 references for just a progress report. Okay, so this is a very good example of citation for literature. So methodology, similarly, it goes in great details. Okay, so I put some notes over here. Pay attention to the meaning of the shapes. Okay, but for her diagram, I think it's rather simple, which can be improved. Okay, okay, again. Okay, for me, for example, this is quite a long paragraph. If I were the student, I would advise her to basically separate into 3 or maybe 2 shorter paragraph. Okay, and then everything is being explained in methodology. Okay, so that we understand the steps. Okay, step A, B, C, and D, and so on and so on. Okay, and look at her equation. Okay, it's proper citation or proper equation procedure. Okay, use math work or other online resources to generate the equation. Okay, please do not copy paste. Okay, please do not copy paste from the paper. Put some effort, declare the variable. See, for example, K is a threshold. Okay, C, what does it mean? So you have to declare. Okay. Okay. All right. So quite a detailed methodology. So I think this is more relevant to FYP1, or even for FYP2. You still can improve um, your report, okay, before the final submission. Okay. Okay. So detail, blah blah blah, classification. Okay. So again, I made some notes over here. Use cross-referencing, okay, for tables, figures, and equations. Okay. So that's her methodology. Okay. For result and discussion, for FYP1, just remember, we just need a proof that you did something. You managed to came up with something during the first semester. Usually, it can be in terms of analysis, um, setup of your experiment, or setup of your boundary condition. Something, okay? It's not result and discussion. It's more to preliminary result. Okay. So if you look at her preliminary result, okay, everything is being explained in detail. A lot of diagrams, plots to help tell the story, to support her story. Okay. Okay. So that's chapter 4. Okay. Okay. And then future work. Future work for FYP1 usually is just the Gantt chart. But at least this student already have a clear plan for FYP2. Okay. So she mentioned in great details. So usually, what students usually put in future work is just, okay, this is my future work from the Gantt chart. It's rather straightforward. Okay, at least explain what are you trying to achieve in the second semester, and how can you achieve that. Okay, put some explanation. Okay, so this is an example of Gantt chart. Okay, all right. So references, please justify. So the total number of references that these students had was 48. Okay? But please make sure you pay attention to the following. Online resources are not considered as high quality references. Okay? And references 46 over here. Okay. So double check, what is this reference about? Is it a book? Is it a manual, or is it a paper? So make sure you check in detail, okay, of the, do not trust Mendeley 100%, okay? Okay. So again, the next appendix is the MATLAB code, okay? All right. So any questions, guys, about what we have covered so far? Any questions? Can you guys still hang on for another 10 minutes? Yes, Mohan. If I change my career, can I submit this report this semester under President by Olaf? You have to talk to our PR. The school has decided to conduct everything FYP2 during the short semester. This is the decision of the school. Okay, if you want to discuss further, you have to make an appointment with Dr. Sani. Have a discussion with him. Okay, just write Dr. Sani, write an email to Dr. Sani and CC to me, because I think this is what Dr. Khairul, the school has decided for everyone. Okay, all right. Okay, if you can spare me another 10 minutes, I just want to share my students, an example of my students' thesis for just chapter 4 and 5, okay, just to show you what he did. Okay, so a bit smaller. Okay, so for chapter 4 and 5, okay, with stories, okay, put with something, always use table whenever necessary for comparison. So we got another question. Sir, the decision has to be confirmed. Yes, it is for the whole school. It's not just for mechanical. Okay, unless the school decided to change the policy, that is what we are going to do lah. Basically, we will have short semester to do the assessment. Okay, all right. So let me continue. Okay, so whenever possible, always use plots, diagrams, tables to explain your result, to support your result. Okay, because if you just write everything in long paragraph, it will be very difficult for the panels to find um, the points that you were trying to convey. Okay, so as you can see here, very short paragraph. Okay, easier for the panels to read. Okay, comparison again. Okay, okay. So in this case, the student explained in detail about the simulation. He was doing simulation of about tidal energy. So before he goes into detail, he described about the simulation aspect. Okay, how he set up the simulation. Okay, it might not be perfect, but at least he gave the background. Okay, what does the value 1 means in simulation? Okay, so that it helps the reader to understand why the student choose a certain value. Okay, right? Okay, comparison of structured and unstructured. So this again, before we go into the detail, you just can't develop a domain and then put some values, get result, and show the result. You need to give uh, some justification of why you choose a certain value in your model. So to do that, that's why the student conducted several studies, the mesh robustness, structured versus unstructured, so that when we read, okay, we understand, okay, that is why this student decided to choose method A, B, or C. Okay, a lot of comparison study. Then only then 4.2.4 finalize the setup for the okay. Okay, so detailed explanation of how the setup happens. Okay, so the result happens, the comparison, okay, between soft and hard behavior, initialization. Okay, but what I want to highlight is the output, the result. Especially this is more concerns about the simulation. Simulation is rather simple. If you have a domain, you put some value in the domain, there will be some output. But how do you know the output is right or wrong? So that's why you have to validate your result with a benchmark, as I said. Benchmark means a result that has been published before. Okay, right. So for example, um, the explanation is quite detailed. Okay, this is the result compared with the experimental data. Okay, see experimental model versus numerical. Okay, so that's how you know your model compare. How well does your model or your output compares with the real data? Okay, a lot of comparison. So these plots were constructed using MATLAB, and you can see the difference in quality. Okay, okay, that was for one disk. Now you have two disks. So to this, what happens? So again, this is the result compared to the experimental. Okay, so as you can see from the comparison, the plot, we can see that the values Well, basically the characteristic of the result, the simulation result, match or closely resemble the experimental data, which is what we want. Okay, so it gives confidence for the reader or for the panels when they check your thesis. Okay, so again, comparison with experimental data. So mostly it's about comparison. Okay, output, then comparison, and then discussion. How you check the value and then how you analyze the value. Okay, so if you look at over here, so it says the comparison of the numerical data, okay, given in figure 4.19. Okay, now this is the basically the result behind the direct analysis. Okay, no way inverse direction. So how do you relate with what you have learned in fluid dynamics, for example? Okay, so you have to analyze and give detail of the discussion. Okay, again, results, comparison, plots, okay, results. Okay, okay. So just quickly go through. Okay, so this is chapter 5, conclusion. So this student basically highlighted, okay, what was the key output from this project, okay, blah blah blah. Okay, so he highlighted the output, the key output, which is, for example, small percentage deviation, which is about 10% roughly. Just 1 second. Okay, I'm having technical difficulties. Okay, okay, so the outcome, technical knowledge gain, you can write down this. Okay, recommendation for future work. So just spend a couple of minutes to read this part. Okay, so this is what we expect of the students. Basically, you want to give suggestion of how the next student or the next people can improve the work. Okay, we don't want to repeat the same thing. So how can the work can be further improved? Okay. So for example, future research can run simulation by mesh dependent study or for using different mesh size, for example. Okay. Okay. So references. So good students usually will provide a good literature review, roughly about 40 to 50 literature review, a good student. Okay, so appendix a lot of data, so sometimes you can't put this in chapter 4 because it's too much. Okay, so just put in appendix but make a reference in the body. Okay, um, all right, so I open the floor for any questions that you may have about what we have covered tonight. Any questions from students? You can use the microphone. Question, guys? Okay, so no question. So hopefully, what I shared in this workshop as well as during the first workshop, hopefully you learn something from this sharing session. Okay, uh, what we are doing right now is just to give you some idea of what the panels expect from the students. Um, so hopefully you learn something from these two sessions and improve your thesis accordingly. Okay. Last round. Any other questions before we end this session? All right, going once, going twice, and going thrice. All right, so thank you so much, guys, for joining me. So stay safe and all right, have fun at home or at the hostel. All right, thank you guys. See you guys later.